Hi everyone, time to change from our usual dev news to delve into GPU testing. As you can see, we went a tad overboard with that thing. The poor bench table is clinging to its dear life, trying to withstand all that weight. I think we may have a world record on that thing. But anyway, we are going to go over the basics of GPU testing, how we approach it, because it's a much more modern approach to what's available out there, and you will learn just about everything that we do and what the latest updates of OCCT brought to everyone. Let's dive in! First, GPUs are tough beasts to stress test. They may be the only component on a setup which is not designed to work at 100%. Or should I say, to deliver its maximum performance at 100%. It's a tad complex, so let me go into detail on that part. When you're playing your regular game, your CPU is doing about 50% of the work. It's managing the game state, where the objects are located, which button you're pressing, the sound, the music, just about everything which is related to the game state and how things are organized, what action you are going to do are handled on the CPU side. The GPU is tasked with displaying graphics, obviously. So it's going to handle textures, meshes, shaders, effects, graphical effects, and whatever. And it's going to display, ultimately, an image. And to calculate that image, it has to wait on the CPU. So there is a time where the GPU has to wait for the information to come from the CPU, and vice versa. The CPU has to know what time it is in real time to calculate where the objects are so that it can position them correctly for the next frame. So it's a complex process where the two components are intertwined. And doing so means CPU is waiting for the GPU, GPU is waiting for the CPU. A while ago, GPUs were working at full frequency at 100%. But this was viewed as a waste because manufacturers had to design a board to withstand maximum power, maximum frequency, and everything should work perfectly fine. Then they realized that in real life, games are working at 50% or so on your GPU. So what's the point of designing it? Can be some views, it's an opinionated way of thinking, but ultimately that's their call. So they decided to go into peak frequency at about 50% power, and then you can go higher in terms of load, but the performance will decrease and the GPU will adapt itself to its load. So it's designed to actually have a very complex curve of efficiency depending on the load you throw at it. This load can vary very quickly, it has to adapt very quickly. This load can be very high, like when you're doing your typical Furmark test, as we were doing in the past. It can be a game, a very light game if you're a Genshin player, a very heavy game if you're an Arc Raider player or Crisis player. This thing can run Crisis, by the way. So yeah, it's a very complex scenario, and it needed a novel approach. And that's what we are doing with OCCT. Now, traditionally, doing stress testing meant going all out. And that's what we're still doing with CPUs and memory, because you don't want to stay like 24 hours waiting for your slow test to complete and give you an error. You want it to happen as fast as possible. That's what we do. We create conditions for stability issues to occur quickly, and if they occur, to detect them and report them. That's how we work. But that doesn't translate well when the peak maximum efficiency is at 50%. In the old approach, you're going all out. You're going Furmark-like, you're going 100%, but then you're not operating at the peak frequency. And your GPU may be stable with a Furmark load, it may not be at 50% in the top frequency. Look at those graphs on my 4070 Ti. You've got in red OCCT, variable mode, 3D adaptive, and you've got in the blue line, you've got Furmark in its latest version. As you can see, we are ramping up in terms of power drawn, while Furmark caps out right off the bat and stays there for the whole duration. If you switch to GPU clock, this is where things get interesting. As you can see, Furmark is peaking at about 2.5 GHz, and we are going actually above. That's because with a lower load, the GPU clocks higher, and we are testing this particular frequency. And more often than not, you've got GPUs which are stable at a lower frequency and unstable at a higher one. And we are reaching peak clocks. It's very clear on that graph. And finally, look at this on the GPU core voltage. We are testing many more states in terms of voltage than Furmark. This is the strength of our test, and this is why we are doing variable load. So how do we solve that problem? Well, pretty easily. Try to replicate every scenario out there and try to adapt yourself and replicate a ton of different loads, and you will hit that sweet spot if you're able to replicate all kinds of loads. That's what we do with 3D Adaptive. So now we have a 3D test which can change its load dynamically. We are going to go much further. You can actually increase the load dynamically and test the full curve in a single click. You can replicate using our switch mode very rapid spikes between two intensities. This is what we call transient testing. The goal being to stress the component, making them go all out, then low, go high, all out, then low, and see how they respond, because those kind of changes in the load are very demanding on your GPU and can produce issues. Also, why do we have several GPUs on that board? Well, it's easy. We can test several GPUs at the same time, even of different brands. We're going to show you that later. And we can test them without a screen attached. So, if you have a crazy workstation dedicated to AI training, crypto mining, or whatever load you can throw on your several GPUs which are attached to a huge beast like this one, you can test it in a single click without going out of your way, plugging a ton of display adapters, testing them one by one. You can just single click, test them all, be done. Now, we worked a lot on that adaptive algorithm. It is very hard to actually achieve an algorithm which can scale coherently on several GPUs of different brands when they all have different operation points. And we updated them a lot in V15. And I want to show you the effect of those changes and what they translate in practice. To do that, I'm going to show you graphs which are taken straight out of our Enterprise Edition. Using our Enterprise Edition, you can record monitoring values, save reports, and then compare them in HTML format so that you can see what changed. Here, I'm going to compare two different versions of OCCT, but nothing stops you from comparing two different setups using the same or different version of OCCT to see everything that changed and if a setup is built correctly and is working the same. We are just taking another approach here where we are comparing different test versions. So here we go. On this graph, you can see the GPU power on a 5080 using our variable test where we actually increase the intensity of 5% every 20 seconds. Notice that I'm talking of intensity because that doesn't translate one-to-one to the load reported by your driver. That's very important. The red line is a new version of the test within V15 and the blue line is V14. And as you can see, we scale lower. We have a much smoother scaling than on V14, which was our goal. This graph shows you GPU clock on that same 5080. GPU clock is peaking much faster than the GPU power. As I said, the point at which your GPU reaches its peak clock frequency is at about 50%, like most of the time between 40 and 60% intensity. That's what we can see here. It peaks around the 2 minute and 30 mark. Now we are reading much lower clocks on the first part of the curve in the newer version, which is exactly what we wanted to achieve. Testing a GPU in low power scenario can also show faults and have errors. Typically, you exit a game, you crash. That's what we want to detect. And the final one for that GPU is the GPU usage. NVIDIA does a pretty good job at translating real GPU load to actual intensity and the actual load. You will see that it's not the same thing for AMD. but it's doing pretty well, and you can see we are peaking, we are still peaking, but less further in the test. We have a smoother curve. Again, our goal. Let's switch to AMD card. This is a 9070 XT, same test configuration. You can see the power ramping up, and the red line, which is our newer test, is also smoother than the rapidly peaking blue line on V14. So again, this was our goal, to be more closer to actual load using our intensity. So far our team has done a great job. Second one is GPU usage. And as you can see, things get on AMD cards a little iffy. There is a very long part in the middle where the load reported is the same at about 70%, when in reality the power was continuously rising. This shows that GPU usage reported by drivers are not an accurate metric. It gives a general idea, but it's by no means accurate. And finally, GPU frequency. This GPU's frequency is peaking a tad later in the curve on the newer version compared to the blue version V14. But overall, this is as expected, this is what we want to see, and we've got a much better curve on the newer version. Now, I told you we can test several GPUs at the same time, but what is the best way to showcase that? Using 3 identical GPUs? Nah, no way. We are going up the challenge. That's why we built that beast. It's got an NVIDIA GPU, AMD, and Intel one. And we are going to load all 3 cards at once. Challenge accepted. Here we are in OCCT's office, and this is where we develop the application. As you can see, the setup is fully wired, all working, and eager to be tested. As you can see, all 3 GPUs are detected by the monitoring on top, and the test as well, since if I select specific here, all 3 are present. So I'm just going to select all, use an extreme workload because that's what we do best, and just click start. And here we are. So you to see clearly, I'm going to filter by GPU and showing only power. And you can see all 3 cards going crazy. 300 watts on the first one, 284, and 150 watts on the Intel GPU, which is a tad less beefy, but still quite a lot of power draw. We're using a 1.5 kilowatts power supply from Corsair, thank God. And we just switched to Linux, and you can see OCCT under Linux, which looks exactly the same as the Windows version. We've got some discrepancies, especially in terms of monitoring. We don't support Intel GPU monitoring yet. It's going to be added very soon. But if I didn't tell you, you wouldn't know this is Linux. So same thing, as under Windows, you've got all 3 adapters detected in terms of rendering, and we're just going to load them all and click start. Let me filter monitoring by GPU, power, and you can see all 3 cards going all out. Okay guys, we're not competing for the most beautiful setup, just for the craziest one. And now, everyone's favorite moment. Concerto del Coil Whine Movement 42. Silence in the room.